actually it comes down to more personality traits than I think any particular technique or skill. Like, you don't need to be good at math, right? How much, calculus and trig shows up in this? Just not very much, right? A little bit of logic, that helps, I think it comes down to more things like traits like curiosity and determination, hard work, that starting early, asking questions when you don't understand something, trying to solve the problem by logic, I think is very valuable, knowing kind of how to think about how to make steps, why this case works and why that case doesn't work, right? Thinking about that logically. Well, it's like the movie theater. Now you guys will all go to sleep. Oh, look, they came back. But that, I think these are the skills that actually kind of serve you the best. And they serve you the best in this class and probably every other thing you'd want to tackle. But there is a lot of time that will be spent here to master this. I can talk about programming all I want, blah, 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 blah. And you can go, oh, yeah, that makes a lot of sense. But when you go to write it yourself, right, it's a very different experience. And that's where, being kind of focused and staying on task and getting help when you get stuck can help you move through that. All right. Any questions about 106? What we do, why we do what we do? You guys have nothing to say. You're afraid of having your voice recorded, aren't you? For all time. Then your parents will come and see that you come to class. You can prove it. All right. My unbiased opinion about why 106B is one of the best courses at Stanford. Of course, I'm not at all unbiased. Okay, it's going to be totally obvious when I say these things, and you guys are just going to have to go along with it. I'm actually a geek, really big time, right? And I happen to love programming, and that's why I'm a perfect fit for teaching this class. I have taught 106B or X more than I've taught any other class that I've taught at Stanford in my time here. And that's because each quarter when we're setting up the schedule, I say, give me B, give me X, because there's no better course to teach. Programming is just awesome. If you love programming, I think there's almost nothing better to do in the world. You have this task, you're trying to get there, you're coding, you're making stuff happen, you're testing, you're iterating, you're running, it comes back around, you see stuff, you build things, right? You can, when you're done, you know it works, right? That feeling when you're writing a paper and you're like, well, is it good enough? Well, I don't know. You could probably go bolster up this argument. Like when a program works, like you can know it. You're like, yeah, that does what it's supposed to do. It gets the right answer. It plays the game. It solves the problem. Finding and fixing that last bug, although debugging is kind of one of the aspects of programming a lot of people bemoan about, I happen to think that if you're driven by debugging, like that is one of the most awesome little detective stories ever, right? It's like trying to figure out why it happened when you did this, when you moved that, why it went this way, and what this effect caused, and then understanding once you make the fix, how it fixes it. Staying up late, I have stayed up late more nights debugging than anything else in my life, and I'm not sad about that at all. So that means I'm in the right place. Hopefully some of that resonates with you. Just a little bit. If that totally sounds really awful to you, hopefully we can change your mind a little bit. But that is in some ways part of what drives computer scientists, I think, is this kind of wanting to build things. We are engineers, right? We're part of the School of Engineering, right? We have this computer science name. Just remember, any subject whose name is something science is not a science. But, we're trying to puff ourselves up a little bit. But we do a lot of really great work, right? And there are a lot of neat scientific principles and theory that underpin what we do. But in the end, I think what drives a lot of us is just the engineering, building stuff that is really neat. It kind of reminds me that my husband's a mechanical engineer. And so I used to be kind of envious because he would always build things. You see the MEs, they're always toting foam core, around the campus, and their paper bicycles and stuff. And it's like, they build all these things. But now, having watched all the things he built, it's like, being an engineer is really hard, actually. You need all these materials, you need all these tools, you need this mill, you need this lathe, you need the hot melt glue gun, which burns the heck out of your fingers anytime you touch it. And to build anything. In computer scientists, you don't need anything. You need a compiler, you need a computer, you need your thought. It's like it's this abstraction we built out of our brains, right? And there's this relatively small set of things that you need to kind of master, and then you can combine them in these very sophisticated and interesting ways to solve all sorts of problems. But there's a very low overhead, and the range of things you can attack with the same set of skills is huge. Like every domain out there can benefit from somebody applying computers in a useful way without fail. There's all sorts of problems where technology is part of the answer. Not the only answer, but certainly something that you can take whatever interest you have and combine it with computer science and construct something cool. I happen to think that what happens in the second course is amazing. The first course, you kind of got to get up to speed, and there's a lot of basic material that needs to get covered. and it does kind of set you on the right path. But in this course, actually, we really get to blossom beyond the basic things. That there's a bunch of really neat and very accessible techniques, right, that a second quarter student can understand and master and do really cool things with. So you can learn how to do something like create a database that has 1 million entries, right, and then ask for somebody by name and be able to instantaneously find that name. Not by looking through 1 million entries one by one. Change the size of it, make it 10 million, make it 1 billion, and still be able to provide that kind of instantaneous access. You're going to learn how to do that, right? And the technique is not, some superhuman thing. It's something very clever, admittedly, but it's very accessible. Taking that same million thing and learning how to sort it efficiently. What if you happen to know things about how it's almost sorted, but just a little bit out of sorted? Are there ways you can actually make it even faster to put it in sorted order? There are techniques, for example, like recursion, that take on problems that you might not have any idea when you first look at the problem how to solve, but once you've kind of got your head around recursion, you can look at that and say, I can write a 5-line function that will solve that problem. And this is the kind of power we're going to give you with our quarter together. So there's a bunch of really amazing theoretical and algorithmic stuff to explore that really increases the kind of things you can do with programming. So I'm particularly fond of it. And as always, I think the section leading program, right, that we have created and built at Stanford is a huge part of what makes our 106 courses so successful. And so having somebody who's individually kind of working with you, meeting with you weekly, and giving you that feedback that's individual and personalized for you and helping you get through the rough spots is a lot of what helps to make the experience very fun and kind of very personal too. So, and maybe I'll say for a second, like, what section leaders do I have here? Any? Not a one. Those fabulous section leaders, where are they again? Did I say they were fabulous? I meant, no. We haven't yet identified who's going to what class, so maybe they're all thinking they're going to go somewhere else, but they're wrong. We'll get some. All right, so 106B, great. You agree? Have I convinced you? Are you sure? Is anybody still hesitant? Something else you're worried about that I can tell you isn't a big deal? Is it a lot of work? Oh, no. I just exude it. It just osmosis. You'll learn it. Okay. Well, let me tell you a little about logistics because there are some just random things, right, that you may want to know about how the class works that the first day I'm supposed to do. Okay. We're going to meet here Monday, Wednesday, Friday, 2:15, 3:05. In glorious downtown Skilling Auditorium. It looks like we almost exactly fit in our classroom, which just means we're all going to be very friendly and cozy. The lectures are being taped and available online, and so that has the neat side effect that you can watch them, you can review them later. You could watch them lots of times, right? It also means that if it were pouring rain and you were sitting at home in your bunny slippers, you could just say, hey, I'm not going outside, and you could turn on your computer and watch. I'm a big fan of having you come in person. That's because I don't want to lecture in an empty room. But I also think there's an interaction there, right? Like sort of the human-to-human thing that I'm kind of fond of. And so I hope that you will make every effort to attend in person as much as you can. But it is nice to know that if you do miss a lecture or you get caught up with something, you'll have a chance to review it later online. We will have sections that will meet once a week, just like 106A. The section leader, right, who meets with you in the discussion section is the one who'll be grading your programs and sitting with you and doing the conferences with them. What you need to do to get yourself into a section, there's a bunch of section times listed in Access, and they're just totally bogus. So ignore all that. What you do is you go to the online, if you go to our class webpage, there's a link that tells you how to sign up for a section. The section sign-ups aren't up right now, but they will go up tomorrow, and they'll be up through the weekend. And you go in and you put in your preferences about what times fit in your schedule or not. And there's this big, you guessed it, computer program, right, that does this magic matching that gets everybody into a section that fits into their schedule that will happen by early next week.
If our schedule changes, what's the last point at which we can change sections?
So the sign-ups will be up from Thursday at 5 till Sunday at 5, technically. So if by Sunday at 5 you know what your section, you've got your schedule fixed, then you're fine. If you happen to change after Sunday at 5 and after the assignments have been made, at that point it's a little bit harder. We can make adjustments, but it's on a very case-by-case basis as to where we have space and where we can accommodate you. So the best thing you can do is by Sunday at 5 have a pretty firm idea about what you can and can't do. I mean, there's a list of preferences, so maybe what you can do is pick things that you know will work no matter what happens. For anything that's variable, maybe just don't offer things that you know might go away. So there's a list of 20 times, and you say I can make these 5, and that way you won't get yourself into trouble on the ones that might change. the workload. Everybody always wants to know, well, how much work? It's a 5-unit class, and it's a 5-unit engineering class. So you get your 5 units worth, I would say. So don't worry about that. I won't shortchange you. We have programming assignments assigned. They're not quite weekly. I think there's 7 of them across 10 weeks. So you can kind of calculate it out. It's about a week and a third for any particular one. The student report that it's about a 15 or 20 hour project, each of them. Some people get them done in less than that. Some people take a little bit more. But I would say that's kind of the mode range for what people are reporting. I do think that of the people who report less, some of those are actually, some people are just very naturally gifted and whatnot, but a lot of them has to do with your habits about how you work and how you make progress. And so if you are one of the people who feels you might be more likely to be on the other end, you can definitely come and talk to me and I can give you some suggestions. In particular, things like choosing to work in the layer where the helpers are on duty actually has really positive effects in that when you get stuck, right, you have easy access to somebody helping you work through it rather than spending an hour or two kind of fighting something that turns out to be kind of simple but just required knowing something that you didn't yet know. Although I'm a big fan of learning things yourself, there's also times when actually a well-placed bit of advice from somebody can save you a lot of time. So as a strategy. There'll be a midterm and a final exam. They'll both be kind of an in-class, so not take-home, open book, open notes. The midterm is actually technically out of class. We're going to have it at night because we need more than a 50-minute period to get any coverage of that. And then our final exam is scheduled in our university scheduled slot. Sadly, that is at the very, very, very end of the exam week. But that's when the registrar puts us, and that's where we need to go. So you may want to take a look at that before you head off to Acapulco for spring break to make sure you're going to be here for the exam.
Is the course available anywhere? Like, is it available?
Unfortunately, our publisher will not allow me to distribute the course leader electronically. They're not exactly very in the modern age on this. So,
Doesn't that kind of hurt the whole
I'm working on it, is the truth. So that, by the time the world sees this, hopefully we'll have some other strategy, but we currently are in negotiation, let's say, but they are not. The nice thing about the course reader is we have not changed it in the last year, so if you know somebody who has it from last fall or last spring or something like that, it has some minor edits and typos that were fixed, but so if you can get a hold of an old one, it's good. We are getting no royalties on it. We're publishing it at production cost. So it's actually, like where it would have been a $100 textbook had it been bound and all snappy. You're just getting what it costs to photocopy and bind the thing, and Eric and I are just, eating ramen. And so it's hopefully cheap enough, right, that you can find a way to get to one or get an old one without it being too much of an obstacle. So. That's it. People, I think, in general, find the course reader to be an asset. We do say it's required reading. It does have a lot of material that's very useful in kind of understanding the course. There are other people who don't make as big a use of it, but there are some sections, I think, that are just really very, very valuable, and other ones that may be more or less depending on kind of your learning style, whether you appreciate more of a chance to read background material and see more examples. And there's also a lot of good sample problems in it and review questions that help to kind of test your understanding. It's tricky, right, because the university in general, it discourages you from giving alternate exams because of you can imagine the issues of having an exam that actually has been seen by some number of students before some other number of students take it. Even though we're all bound by the honor code, it does kind of create a situation where there is some temptation. And so it's possible it could be a little bit early, without a lot of gap, but I don't think early enough to make a lot of help is the truth, right? We can talk about it though, but the current plan is not, I would say. So if there's something really important about that, that you definitely know you're not going to be around at the end of the exam week, that's going to be a problem for us. You need to talk to me. And then a little bit about compilers that we use C++, and we also use some custom libraries, which limits us to distributing on a certain number of platforms we've had a good chance to test on and work with. So the compilers that we have support for, right, is Xcode on the Macintosh. Xcode is Apple's free developer tool, so anybody who has Mac OS X can freely download that and install our libraries. We're using Microsoft's Visual Studio version 2005 on Windows, and we have an arrangement with Microsoft where they have distributed the software free of charge to students. So if you would like to install that on your own Windows computer, we're going to give you some handouts on Friday that tell you what you need to do to kind of go get the compilers and get it installed on